Hi everyone. Sorry for starting a little bit late. I had technical difficulties. Hopefully everything is going to work now. So I'm not going to talk about choose your own topic. This is the topic of anyways. I'm going to talk about OAuth, Json Web Tokens, and OpenID Connect in a choose your own adventure type of way. So about 18 months ago, I started a new job at Auth0. We had an identity management platform as a service, and the technology was using OAuth and OpenID Connect and all that stuff. So when I got the job, I kind of had to learn all of that. And I kind of heard about it before, but I just didn't know where to get started. And it was really complicated for me to learn all of that stuff. So I figured, I'd start doing talks about it and explaining in a way that is more easily understandable for developers how all of this works. Now I gave those talks for about 18 months, and I came to a point where I was like, yeah, everybody knows all that stuff now. So we kind of call that the curse of knowledge. When you start repeating something over and over and over, you feel like everybody knows about it. So I had to write new talks, and I was like, well, you know what I'll do instead of giving information to people, I'll ask them what they want to learn, and then we'll go with that. So hopefully everything will work, and we will be able to do this. So very quickly, first of all, hi, I'm Joel. I'm Canadian. I'm French Canadian, technically, or more. So that's the charming accent. I used to be a technical evangelist at Auth0, but I just downloaded the slides to install them on another machine. So that's my old Git repository. I currently work at Red Hat as a developer advocate. And if you have any questions about Red Hat, don't ask me. I can't even get my goddamn Linux laptop to work. So. I'm also an author. You can find me on Udemy, Egghead, and so on. I'm organizer for Nomad.js, which is a meetup group for people that don't have a local meetup. Look us up, nomadjs.com. Guy would also be speaking next month, I think. So cool. Yeah, and I'm an astrophysicist turned engineer. I love Twitter as well. So if you ever want to get in touch with me, Twitter, that's 2 underscores. It's not very obvious, but Joel 2 underscores Lord. That's me. I get very, very excited whenever I have Twitter notifications. I also make my own GIFs. And sometimes I post some smart stuff. Most importantly, I have stickers. You might find them somewhere around there. So that's kind of my pet peeve, like password hygiene. So I have stickers all over the place. If there's not any more or can't find any, just come and see me. I'll be more than happy to give some to you. All right. So like I said, this is not your normal talk. So please take your phones out and go to this address. Now nobody loves to raise their hand, especially if I'm going to ask like, who doesn't know anything about OAuth? Like nobody's going to really raise their hands. Well, people are shy, right? So let's try to use an app. All right. Let's see. So if you go to this URL, you should have a spinning cursor. It just says waiting for next question. Just like see a few nods. All right. Let's try to see if we can push a question to your phones there. So, the music's on. Okay, so I'm going to ask a few questions around the talk and how you want to make your choices. So you should have the question on your phones now. So do you want to raise your hands every time I ask a question? Do you want to just shout the answers, use the app? Or, you want to see Phil?
I would like to shout.
Yeah.
Shout, please.
My blank screen says yell and
Shout.
All right, well, it said use the app. So we're going to use the app. Cool. It actually worked. Trust me, I'm more surprised than you are. All right, moving on. All right, let's get to know each other a little bit. So I'd like to know, what's your background? So first of all, get your phones out. Pay attention. Get your phones out. You have 5 seconds to get your phones out, or else you're going to miss it. So what's your language of choice? What should we use in our code samples? I want to use JavaScript. To be honest, I'm always biased. The first one on top is the good answer. Alright, we've got JavaScript, we've got Python. Interesting that we're a Python t-shirt today. PHP, anything else?
Ruby.
All right. Okay. But it's not true. It's not always the first one, but it just happens. Yeah. Okay. Well, sorry. I picked JavaScript. Okay. So the code samples will be in JavaScript. Sorry for you guys. All right. Another one. Get your phones out. All right. You backend developer, front-end developer, full stack. If you're doing JavaScript, of course, you're full stack. Other, a few others. PMs, marketing, communication. All right, it seems like we're gonna go with full stack. That's good. All right. Okay, good. So we have JavaScript full stack developers. That's all good. I think we're ready to get started now. So let me talk about OAuth. So OAuth is, and like I said, when I started looking into this, it was kind of hard for me. There's a lot of, if you look into OAuth, there's a lot of diagrams and arrows and boxes and stuff, and a lot of vocabulary very specific to security stuff, and it's very, very dry, a lot of very heavy documentation. And it kind of took me a while to kind of understand what it was and why I should actually use it. So basically what I got out of this is that OAuth is simply a way to, or simply a protocol that describes the way information should be shared between different machines in order to authenticate or authorize different resources or people to different resources. Different resources to people. So it's just a way to describe those flows, basically. It's a very, very loose protocol, and that's why it's a lot of text. And it was designed by just all of the giants of the industry, and they just all got together and decided they needed a way to share information between their different servers. But of course, nobody wanted to give their secret sauce, so they kind of got together and came up with this very, very loose standard. And essentially what it describes is a way to share different tokens so that information can be shared using what we'll call tokens, which we might see later, depending on what you want to do. So tokens are just used, and it's just a piece of digital information that gets transferred. And when you're using OAuth, you have this concept of a third party that will authenticate your users or take care of all the authentication part. And then that will generate tokens, and that token will be able to be digested by your APIs to validate if the user has access or not. So that's pretty much all there is to OAuth 2.0. All right, time for a question. Get your phones out. How familiar with OAuth are you? Right? Okay, that's good. Not too much, so I can start with some analogies. I think a little bit better way to do it, so let's see if I can. The funny part about this thing is that I have like all those slides for different branches, and like I'm never gonna use some of them. All right. Cool, so that's good. So it seems like people don't know too much about OAuth, so we'll try to use an analogy. Because we're doing a choose your own adventure, you know, I decided I might as well go all in. So, picture this. You wake up in a forest clearing with nothing except your clothes on. You don't remember how you got here. Your head hurts a bit. The only thing you remember are the words, horse battery stable. There's a path in front of you. After walking for hours, you finally see a village up ahead. Finally, you'll be able to find some food and a shelter. As you get to the bridge, a troll jumps out of nowhere. Who dares enter without my permission, he screams. Get your phones out. All right, so a troll comes in. What are we going to do? Are we going to pay him? Try to bribe him? Are we going to try to beat him up? This seems like a very popular option. Are we going to try to negotiate? Right, negotiating it is. It's good. That's good. Okay, so you tell the troll, I don't have any money, but maybe we can find some sort of agreement. The wizard told me a hero would come, says the troll. If you can prove to the wizard that you are the said hero, then I will let you in. So you head to the wizard tower. The place looks abandoned. Anyone here? The wizard appears in front of you. prove me you are the hero, and I will tell the troll to let you cross the bridge. We have to prove our identity to the wizard. So how are you going to prove that? Are you going to scream horse battery staple? Why would you do that? Are you going to show him your hands? Security vision to track down the hero. I'm going to explain that one later. All of the above? Seems like you people like screaming. All right, horse battery staple. Maybe you shouldn't just shout out your passwords. All right, get some of my stickers as you get out. Don't share your passwords with anyone. But sure, the password works, so the wizard is fine with that. So you prove to the wizard that you are the prophetized hero. So he hands you a scroll, he tells you, show this to the troll, and he will let you through. So now that you have the scroll, you head back to the village, confident that you'll be able to get in. You again! Can you prove you are the hero? So you show him the scroll. Oh, sorry about that, hero. It's a Canadian troll. Sorry about this, hero. I will let you in now. The troll lets you in, and you finally get into the village just before dark. Quest complete. Congratulations, you've done your first quest today. So, what have we learned here? We talked about the implicit grant in OAuth. So the implicit flow is a flow of communication, like I said, that will help you to authenticate and get access to resources to an API. So the way the implicit flow works is kind of your typical architecture in JavaScript, where you have a single page application on one side, and it's trying to access some data directly on an API. So probably an API that you've built. So you're trying to get access to that information directly. So your single page application will validate if the user is authenticated or not. And if he's not, it will redirect the users to an authentication server, the wizard in our story. So the authentication server will validate the user. That could be done through passwords, could be done through biometrics, showing the hands. It could be done through single link, which was kind of the carrier pigeon thingy I was trying to show. Or all of the above, which is even better. Always try to add multi-factor authentication whenever you can. So your authentication server will validate who you are, and then send back an access token to the single page application. Once you have this access token, you can store it on your single page application. There are different ways to store it. Typically, you would try not to store it in local storage or cookie or anything. Just keep it in memory if you can. And you would use that to do your request to your API. Now, every request that you do to your API will have this access token with it, so you'll be able to get access to the data on the API. All right. Oh, I didn't have a warning for that one. Sorry. This question really makes me nervous. Okay. Okay. So that was the implicit flow. There's another one that is often used, which is a little bit more secure as well, which is called the access code grant. So should I go with an analogy with that one? It seems like majority decided that we should. Sorry. All right. As you get into the village, you are greeted by the mayor. I can provide you with food and shelter if you agree to do a quest for me, he proposes. And you've all agreed to do it. Right? Good. All of our treasures are locked in a cave nearby, and only the enchantress knows the code to get in. If you are the true hero, like you say, maybe she'll give you the code to get in. So and off you go again through the same path that brought you here, headed for the enchantress castle. You walk days and nights through the forest, fighting hordes of evil creatures that are not relevant for this talk. And finally, you arrive to the enchantress castle. You knock at the door. Ah, hero, I've been expecting you, the enchantress says. It has come to my attention that you seek the code to get into the cave. If you can prove to me that you are the true hero, I will help you. All right, fine too. I you probably guessed that one. So let's get ready. How do you want to prove that you are the hero? So you can show the wizard scroll that you still have with you. You can engage into a fight. goes for a second. That would have been the end, right? Like you would lose against the Enchantress, sorry. Or do you want a short horse battery study poll? Alright, you guys are really good at this. So you're gonna show the wizard scroll. Oh, the wizard already authenticated you. Fair enough, she'll let you in. A single sign-on, that's very clever. Alright, so you truly are the hero from the prophecy. Still, I can't trust you with the code. Bring this carrier pigeon to the mayor, and he'll be able to get the code with it. Equipped with your carrier pigeon, you head back into the village. Back in town, you quickly find the mayor and show him the pigeon. This is great, exclaims the mayor. He adds his seal to the pigeon message and lets it go. You wait patiently for the pigeon to come back, and the pigeon comes back with a message. Thank you, hero, says the mayor. This is a message from the Enchantress. She shared the secret code with me. The villagers are then able to access all their treasures and even share some of it with you. Everybody's happy, quest complete. So what have we learned here? So this one was a little bit different. So you never had access to the actual code of that cave, right? But you were the messenger in order to help the villagers to get to that cave. And that's what the authorization code grant is. So in this case, we have a server in the middle. So you have your single page application once again that connects to a backend, which serves your page. You can have a session open, and you have some data on another API completely at the other end. Typically, this would be an application that tries to access some information on your Twitter feed, for example, and display some information from Twitter. So you're accessing a third-party API over there. So the server will check if the server is actually authenticated with that third-party API. And if he's not, you will be redirected to the authorization server. Same type of thing once again. You validate that the user is who he says he is. You can use single sign-on, like you did. And then you send back an access code back to the single-page application. Now, this access code is not the same as an access token. It doesn't give you access to any resource. The only thing that it gives you access to is that you can send that back to your server, and your server using that access code will be able to get an access token and use that access token with the API. So the big difference here is that you never had access to that access token. The access token is a very, very sensitive piece of information. If somebody gets a hold of that, he can impersonate your users. So you want to be very careful with that type of information. So by using the the authorization code flow or grant, in this case, you never have access to that data. It's all stored on machines, and there's a machine-to-machine communication going on. It's much more secure. Everything is kind of in a black box over there. So there's less chances that it gets actually leaked. So you now have access to all of that data. Congratulations. You're all OAuth experts now. So let's talk a little bit about the tokens. So I've mentioned tokens are being shared all over the place. So what are they exactly? So tokens can take multiple forms. If you're in the Microsoft environment, which I'm guessing because there's a lot of people that said other in the languages, there's the whole WS federated stuff. I'm a Linux guy, right? I know nothing about Microsoft, at least since the last week. SAML, if you're into Java, you're probably going to use something like SAML for your tokens. You could use custom stuff. Basically, a token is just a piece of digital information and just carries information between the different machines. That's all it is. The one that I'm going to talk a little bit more about, the one that I'm more comfortable with, is Json Web Tokens, which uses JSON as a way to exchange data between the different machines. So Json Web Tokens, there's supposed to be a picture there. Not of a token because it's just a piece of digital information, but something. So there's an official spec there. So RFC 7519. It's in proposed state, and that is very important because in the spec it says that they should be called JWTs, and it really bugs me. It's just like calling a GIF a GIF. Like it's ugh. So please, if there's one thing, it's called a JWT, not a JWT. And if I can convince enough people, we can potentially put that back into the RFC and get it approved. And basically, the only thing it does is that it's used to exchange information between different machines. That's its only purpose. ready for another question? Get your phones out. How familiar with Json Web Tokens are you? I know some people use them. You not know what they are at all. Have you used them but would like to know a little bit more? Or are you familiar enough and you'd like to skip this? Ooh, it's very tight. It's exciting. All right. So it seems like we're going to talk about Json Web Tokens. So let's talk a little bit about Json Web Token, what's their anatomy, how they're built, what they're used for, and so on. So Json Web Token looks like this. So like I said, it's just a piece of digital information. It's just a string. And they typically look like this. As you can see right away, there's no special characters in there. It's all alphanumerical characters. Kind of lightweight, relatively lightweight, so easy to carry around. And it's composed of 3 different parts, which are separated by a dot there. So let's take a look at the header. The first part there, let's focus on this one. This turns out to be a base64 encoded string. So if you use your browser's function A to B, you can actually convert that, and you will get a JSON Web object. Technically, it's a JavaScript object, anyways, JSON object. Technically, it's a string, so you have to still convert it into a JSON object, but you'll get something like this. So in this case, it will specify what this is. What is this? This is an object of type JWT. So we can know what this is, and it will also specify what's the algorithm that is being used for the signature. And I'll come back to the signature. The second part is the payload. So it's the part in the middle. It looks a little bit like this. If you're clever, you might notice that they both start the same way, EYJ. That's because they're both base64 encoded strings. So you can use the A to B function again, and you'll get a JSON object again. They can have multiple, a bunch of different key value pairs here. They are called claims, but it's just a key value pair. Typically, some of them are reserved. No, not typically, but some of them are reserved claims. So you should only use them in a specific context. Sub is one of them. So it's the subject of the token. In this case, it's the user ID. Typically, it's the user ID. IAT is the issued at timestamp. There's a bunch of them that are reserved. You shouldn't use them. They all have 3 characters. So if you want to be safe and add something to your token, just use more than 3 characters. And you can put whatever you want in the payload of your JSON Web Token. In this case, I'm putting the name of my user, so I'll be able to use that in my UI, for example. All of that information is not encrypted, though, so be careful of what you put in there. Don't put credit card numbers and things like that, because it's all, like you've seen, you can just use the browser function to actually decode that, so nothing is encrypted. Finally, we have the signature, which is the last part here. And the signature is generated with a signing algorithm. So signing algorithms are a very easy compute function that will perform a mathematical operation and output a very specific string based on the content that it has and a secret key. And it's very, very easy to compute. So what will happen is that you will check this function, or you will create one and append it to your JSON Web Token. If you want to verify if it's valid, you'll just generate a new one and check if they're both valid. So there's no way to reverse those functions, but they're very easy to generate. So in this case, we're going to take the header, the payload, concatenate those, and encode them with a secret key. If you have to play with JSON Web Tokens, JWT.io is a very good resource. You can actually go in there, paste in your JSON Web Token somewhere in here, and you'll actually see the content encoded on the right. You can verify the signature is valid and so on. So there's a bunch of different things that you can do here. A very, very good tool if you ever have to play with JSON Web Tokens. So in order to use JSON Web Tokens to secure your applications, you'll need 3 things, right? We've talked a little bit about it already. So you need your authorization server, and then you'll have an API that will be protected by those JSON Web Tokens. And you will have a front end that will be in charge of delivering that JSON Web Token. The authorization server, the way it will work at its most simplest level, and I mean, it gets a lot more complex than that. There's a team of, I don't know how many 100 engineers are working on this at Auth0, and they've been working on it for many years. So it's definitely a little bit more complex than what I'm going to show you today. But at its most simple level, you have a GET request that you can do in order to get a form. In this case, it's just going to be an HTML form, very, very simple stuff. And just to validate the username and password. And then we're going to post all of that information to the server again. And the server will validate if the user says ER, if it's the right password in this case. And we'll send back a JSON Web Token and redirect the browser back to the original application. In code, so you picked JavaScript, or I picked for you. And we're just going to look at the post part. The GET is it just simply sends an HTML form. So if you do the post request, the first thing that you'll want to do is validate if the user, well, actually, you'll want to validate if the request is valid. So is there a username and a password there? If not, you can immediately reject the request, send a 400, and that's all using Express as a backend. Once you have a valid request, you can try to find the user in your database. Now, here's a very cool tip. When you're using a plain text password, it's very, very easy to do. Well, don't do that. So you can find the user, matching user name in your database. Use whatever way you want. And if there's no matching user, you can send back an error message once again. If there is a matching user, though, you will generate a JSON Web Token. So in this case, I'm using the JSON Web Token library available on npm install, which we've all learned earlier this morning that you should not use. But npm install will take care of installing all of that for you. And it's a library that will generate JSON Web Token. So you pass it whatever payload that you want and a secret key, and it will generate a Json Web Token encoded with, or with a signature using that secret key. And finally, you redirect your users back to the original application where they came from, and you append the access token as part of the URL. On the front end, the one thing that you need to do is to add this header to all of your outgoing requests. So if you use something like Axios, it's easy to just add it to each outgoing request, and you'll just add authorization header. You'll say bearer, and you just put in your JSON Web Token there. On the API side, you'll want to protect your data. You don't want anyone to actually have access to it. So what you'll do is that when you get a request into one of your routes, once again, I'm using Express in this case, you'll check if there is an authorization header present in the request. And if there's not, you can immediately send an error back to the users. If there is an authorization header, you can check, you can split using the dot, and you can find the information, you can find the payload, you can do some stuff there, you can validate, you can decode it, extract the payload, and then you'll be able to take a look at what's in the payload, does the user have permissions, and so on. So there are libraries to help you all with that, but I just kind of wanted to lay it down in code here. So in this case, we're checking the permissions. If the user has admin set to true in the payload of the JSON Web Token, then we'll give him access to the admin section or the admin information. All right, time for a question. Want to see a demo? Oh. I mean, you can't leave at any point, right? There's cookies outside. This is also just an excuse for me to take a sip of water, in case you didn't notice. All right, demo it is. So, I'm in my application, which is my slide deck. And you can see that I'm on localhost port 3000 up there. And I'll just log in. When I click login, I'll be redirected back to the authorization server in order to validate my identity. So you can see that I've been switched over to localhost port 8080. And I provide the address so that the server knows where to send me back once I'm authenticated. So it's an ugly little server. People in security don't really care about UI stuff, right? So let's put in my username. Please close your eyes. All right. So you can see in the address bar there that we've been redirected back to the original application. So the authorization server has checked, found my username in the database, found that it was a matching password, generated a JSON Web Token, which is this one, and sent it back and sent me back to my original application. So now I have this token. I'll just put it here because I need it later on. I can decode it. And you can see the content. I don't have admin permissions in this case. You got my username. I've got some timestamps that were automatically added there because of the library that I used. So I've got the issued at timestamp as well as the expiry timestamp. So if I want to contact my API, oh, those are so cute. I'm using HTTP cat. Is everybody familiar with HTTP cat? Yeah, okay, well that's an HTTP cat there. All right, so if you try to access the API, you'll get a message saying, well, there's no JSON Web Token or no authorization header in this case. So I'm just going to load the JSON Web Token. And if I do my request now, you can see that I have the welcome message. And if we look at the request, there it is. If we look at the request, we see that I've simply added here the authorization header. It says bearer and the JSON Web Token. So on the front end part of things, the only thing that I need to do is to add this token as part of every outgoing request. So that makes it relatively easy to use, and it's easy to consume, easy to pass around as well. So to secure your applications, if you're working on the back end, ideally you would use a middleware to add to all of your routes. It makes it a lot easier than to decode the JSON Web Token every time. So you can use a middleware to check for that. On the front end, you will add the authorization header. And basically, I highly recommend to delegate all this sensitive information to a third party, one that you don't have to deal with it. I mean, you wouldn't want to trust me with your passwords because obviously I'm using plain text password and all that stuff. And oftentimes, as developers, we get a little bit, lazy, for lack of a better word. So you can use a lot of OAuth servers that are openly available to you. You can use Google servers, you can use Facebook servers. Not that I really trust them with my data, but you get the point. Or, Auth0. All right, we have a little bit of time left. Yeah, let's go for another question. We don't have a lot of time left. So I can continue talking a little bit about OpenID Connect. I'm not sure if everybody's familiar with that. I can explain OpenID Connect. Definitely I'm going to go with the show you how JWTs can be hacked. Seems to be, let's just end this talk now. Inside there's cookies. All right. Hacking JSON Web Tokens. I'll try to go really quickly on that one. I don't want to run too much over time. So I'll just log in again. Yeah, same one. Okay, we're back to our application. So you've seen this already. I got my JSON Web Token back. I can decode it, so I get pretty much the same information. So if I try to access the API and I try to get access to the admin data, I'll get no authorization header found. If I load it, I'll get a message saying, hey, you're not admin, so you can't access that data. So let's see if I can actually decode that information. It's not the prettiest UI. Okay, so I built a small decoder here, or editor for my JSON Web Tokens, so I can actually decode that. Take a look at what's inside. So I've got JSON Web Tokens, signature HS256. I've got some data here, admin, files. Watch me. All right, so I'll change that to true. Save that, copy. Go back to my API. Paste this in, and I've got admin rights. All right, so that proves that JSON Web Tokens are not very secure, right? So there's one thing that I didn't do in my API. I didn't do a signature check in this case. So I simply check for the presence of a JSON Web Token. So one thing that you have to be very careful is to actually validate that this is a valid token and has not been tampered with. So don't rely on the presence of a JSON Web Token, but check for the signature as well. So you would take the JSON Web Token. I'm going to go quickly about that, but if you want to know more, come talk to me afterwards. So you check the signature, generate a signature, validate if the signature matches. And if they do, if they don't match, then you know that the token has been tampered with. So you can throw back an error message saying, like, this is an invalid signature, and reject the request. Now, another interesting way, take this token again. And I really want those admin permissions. I'll do that. And I can change the algorithm as well to none. Take this, copy this, go back to my API, paste this in, and bam, I've got admin rights again. So that's another easy way to hack your way into a system that uses JSON Web Tokens. It's called the algorithm none attack. So algorithm none is actually part of the spec. It's a very important part of the spec. It's used in contexts like IoT stuff, where you already have a very secure connection. Nobody can actually get access to any of those. And you want to minimize the data as much as you can, just like David mentioned in the talk previous to mine. So you want to reduce the data that goes over the wire. So you could put algorithm none. Now, if you don't accept that, make sure that you actually do a check on this, or that the library that you're using does the check, so that it refuses requests that are using algorithm none. Now I'll try this. Let's see if this will work. It might take a few seconds. Like I said, I've installed this whole thing like 2 minutes before I got on stage on a machine that I don't know, so I'm kind of not sure what's going to happen. Matt, your machine is starting to, the fans are going on. Maybe I broke it. Let's just give it a few seconds more. Oh, there it is. So I found the key. Took 33 seconds, but I managed to find the secret key that was used in the signature. So once again, now that I have the secret key, I could basically create a new JSON Web Token, use that, and I'd be able to get my admin permissions, because I'd be able to create a new signature. So your signatures, make sure that you keep them secret. Don't share them with anyone. Don't use HMAC if you can avoid it, because they are technically very easy to break into or to brute force. Basically, the code that I've shown, and it's going to be shared afterwards in my slides, but it just brute forces it. It just tries signature A, and then it tries B, and then it tries C, and then it tries AA, and AB, and so on. So it just tries all the potential secret keys until it actually finds one that matches the signature that was generated there. So be careful if you're using HMAC. If you do use it, use strong keys, 64 characters, use small lowercase, uppercase, and so on. So use longer secret keys. And finally, there's another attack that I wanted to show. So I'm using another server here. And on this server, this is a completely different authorization server. As you can see, it's much more secure. You can see that already because it's a password field instead of text. And on this server, I actually have admin permissions. But this server doesn't know anything. No, don't say. This server doesn't know anything about the original API. But I can still take this token and decode this, and it's been issued by a more secure server. It's meant for another API, but I do have admin permissions here. But if I use this token, I can actually get admin rights on a different API, on the original API. So that's called the confused deputy problem. It's a very, very simplified way to actually show it. But it's when you've got permissions on a certain machine, more elevated privileges, and you try to use those on a different machine, and it actually lets you in. So there's ways to make sure that this doesn't happen. There's a bunch of different claims that you can use. So who issued that token? Who is this token meant for? As well as the expiry timestamp. So you can check those. And the last pitfall that I wanted to show you is this one. And this is my console here, and you can see that there's a comment that says, this is some malicious code logging your JSON Web Token, and my original JSON Web Token is right here. So in this case, it's not too bad, it's just logged into my console, but this could technically be logged or sent to another server, And like I said, if somebody gets a hold of those JSON Web Tokens, they can impersonate your users. So be careful where you store your JSON Web Tokens. If you store them in local storage like I did, any library, any JavaScript file in your node modules folder can actually have access to them technically and use those and impersonate your users. So don't store them if you can avoid it. No storage is safe. Keep them in memory. And we're almost done. So I'll let you with a few resources. They're all available. They're going to be on Twitter in a few seconds. On this, thank you very much. Thank you.